Alright, so here I want to do eigenvalues, eigenvectors of a matrix. There are, if I click here, um, there are a number of commands here for eigenvalues, eigenvectors. There's like characteristic polynomial, factored characteristic polynomial, and didn't realize that was there. And then it says eigenvalues, it says eigenvectors left, also right, eigenmatrix right, also left. What I find is this works the best for me. Now, the left and right, the thing you have to worry about is, right, when we do eigenvectors and eigenvalues, we say a times x equals lambda x. So x is on the right. So you see we need eigenvectors right, not left, or eigenmatrix right, not left. And what I think I've found is that if you do just eigenvalues, it defaults to the left, not the right. So I find I just like this command, eigenmatrix right. It tends to it gives me the most readable format, and unless I need to do something else, that's what I do. So here's a let me space over here so we can see it a little better. Here's a random 3x3 matrix. Truly, I just said give me random numbers between -50 and 50, and I made that matrix. So here I'm getting two outputs. That's why I have the D and the P. So D is the diagonal matrix that has the eigenvalues in it down the diagonal, and P is the corresponding matrix where its columns are the eigenvectors. And I do eigen, I define A, then I say A eigenmatrix underscore right. And then here I just show D and I show P. Now these commented things here, we're going to show you that in a minute. And then B, I just said, well, I should be able to take P times D times P inverse and get back to A. So B here should look like A. So 7, 28, -32, and so forth. And so I show that. So I hit evaluate and come down here, and so that's pretty big. Now part of it is I have this at 200%, so this thing's, takes up a lot of room, but notice, there are the eigenvalues. So one real eigenvalue and a conjugate pair of complex eigenvalues. Okay, so we have that, and then here is our matrix of eigenvectors, and the eigenvector that goes with 37.33 is 1, 2.898, 2.998. So, so these are really close to 133, and then the other eigenvectors are complex. And then when I do that multiplication, I get 7 plus, and here, I've got the square root of -1, but it's e to the -15, so it's essentially it's 0, which it should be, right? Those were all real numbers up there, so I get 7, 28, -32, and so forth. So now here's a case where it might be nice to limit the number of decimal places. And so I looked some stuff up on Google, and I found this way. You can't just say round, unfortunately. And so if I comment out the original things here and show these, what this does, so it, I think what it does is it, best I can tell, is it takes whatever object I'm working with here and converts it to string, to text, but it does it in a particular way, and then there's what they call lambda functions, where you say lambda of x, and it's always this lambda of x, and then here is the function, and what it's doing is for each x, it's doing a string, but only doing 3 digits, and sending that all out to show it. Now, here's the thing. That's not 3 decimal places. It's 3 digits. And so we'll see, so this isn't the greatest thing, but it's not bad to limit things a bit more. And so you see when I print it this way, a little bit easier to read. I see the 37.3 and then 28.8 and the minus and plus 45.5i. So it's nice. It makes the I for the square root of -1. And then for the eigenvectors, notice it lost that question mark stuff with the zeros and so forth, and it did do some rounding, so it said 3.00, 2.99, and so forth for that. And then when I multiply it back together, I still see some error stuff due to rounding, but this is e to the -18th. Well, not e, but 10 to the -18th. The exponent is 10 to the -18th, and so it's 0, and so this part's 0, this part's 0. Here it actually gave me a real number of -1, and these parts are 0. So it doesn't take much to get those eigenvalues and eigenvectors, and you can kind of check and see that they do work. And so there is a video on just a general matrix with eigen values and eigenvectors.